Alright, so today we're going to look at graphs of exponential functions. The part we do, especially at the beginning, should be a review, but you let me know if you have questions. Right? So, as we begin, on your paper, you should see kind of like a little introductory box with information that we're going to fill in as soon as my screen changes. Okay, so exponential functions. The parent function that we're going to use is y equals a times b to the x power. Okay. So when you deal with exponential functions, x is in your exponent. Okay. B is your base, and then we'll talk about what a does in just a little bit. So if b, your base, is greater than 1, the function is an exponential growth. Okay. And is increasing. So conversely, if b is less than 1, so you're talking like a function, 1/2, 2/3, 1/5, whatever. If it's less than 1, the function is an exponential decay. So it is decreasing. Now, these graphs do have a horizontal asymptote. They don't have a vertical. There aren't any bad values, but it does have a horizontal asymptote. For the parent function, the horizontal asymptote is at y equals 0. But that will change depending on how your function changes. And what this will represent, one side of the graph levels out at that horizontal asymptote. Just one side though. One side does one thing, one side does something else. So, I need you all to get your calculators ready. I need you to go to y equals. I need you to put into y1 that first function. It's listed as f of x equals 2 to the x power, so go to y equals, and put in 2 to the x power. X has to be the exponent, so you're going to use that caret key. Start out in your standard viewing window, so Zoom standard. The graph on your paper is a 10 by 10, so you don't have to worry about changing anything there. But what I need you to do is, I need you to go to your table. I need you to give me some points, some nice points that I can plug in. Zero, 1, here's your y-intercept. 1, 2, 2, 4, 3, 8, right? And that, then the next one will be off the screen. What if I do a negative, like a negative 1? What's that going to be? -0.5. Okay. Alright. And then in your table, as you notice, as your x values become more and more negative, what happens to your y values? Do they become negative? No, they just get smaller and smaller and smaller. Alright. So this side of the graph, the left-hand side of the graph, levels out. The right-hand side of the graph is going up to infinity. Okay, so that does represent an exponential growth function. Shouldn't be a big, huge shock. B, your base is 2. That's bigger than 1, so it's growth. So now let's talk about some domains and range, some indicators. Domain, your x's. How far left, how far right will your x's go?
Negative infinity to positive infinity.
Good. And we'll use interval notation, negative infinity, positive infinity. If you want to put all real numbers, that's fine. And you don't have any bad values. Range. Just for this particular problem. Okay? Now, hopefully you're pretty okay with the idea that this end here, the right-hand end, does go up forever. Okay? But at what y value is this left-hand side of the graph leveling out at?
Right.
Is it ever getting negative?
No.
No. It's getting closer and closer and closer and closer to the what?
X-axis.
To the x-axis, okay? So actually, before we do range, then that means you've got a horizontal asymptote there. Okay? So I'm going to draw that in with a dashed line. If I weren't afraid that my screen was going to get hung up again, I would do it in a different color. Okay, so there's your horizontal asymptote. That means the range. The y values are going up forever, but they're leveling out at 0. Since they'll never actually get there, they're leveling out there. We'll use a parenthesis instead of a bracket. Starting at 0 and going upward to infinity, and infinity always has a parenthesis. So your y values are going to be bigger than 0. They won't actually hit 0, okay, but they're trying to level out at 0. Now the end behavior piece, that's what we talked about a little bit yesterday. If you need to go ahead and tell yourself x goes to infinity, that's the right side of the graph. As x goes to negative infinity, that's the left side of the graph. So, as the right side of the graph goes to infinity, as your x's go forever to the right, where is your function going? Is it going up? Is it going down? Is it leveling out?
It's going up.
It's going up. And since it's going up forever, we say it's going up to positive infinity. Okay, the left side, as x goes to the left forever, as x goes to negative infinity that way, what is your function, or what are your y values getting close to?
0.
They're getting close to 0, exactly. And the y-intercept is nothing new. That's the point, 0, 1. But it's good to focus on that point because in a few minutes when we talk about transformations, that y-intercept is really easy to see, okay, how has that point been shifted off of the y-axis? So as we look at the next example, the graph is almost identical, okay? Since your base is 3, is that exponential growth or exponential decay? Is your base bigger than 1? It's growth, okay? So it's going to look almost identical. The only difference is some of the points. Now, if you put y equals 3 to the x power into your calculator and go to your table, the y-intercept is still the same, right? You still have the point 0, 1 on your graph. Now, the reason for that is this. If this 0 is an x value that you're plugging in right there, any number based to the 0 power is what? Any number raised to the 0 power is always 1. Okay? So unless you start transforming your graph, that y-intercept is going to be 1. Because any number to the 0 power is 1. Now, beyond that, yeah, your points change a little bit. Like the point on the graph, 1, 3, is that right? 2, 9, negative 1, a third. And then this side levels out. This side goes up forever, a little more steeply than the other. But long story short, it's essentially the same graph, just a little bit steeper. Okay? So since it's essentially the same graph, just a little bit steeper, what changes over here? Does the domain change? No. Nope. Still all real numbers from negative infinity to infinity. Okay? It leveled out at 0, so that's where my horizontal asymptote is. Okay, so if the left-hand side levels out at 0, that's where the horizontal asymptote is. Does the range change?
Nope, it's the 0 to infinity.
Right, still getting close to 0 on the left side, but it's going up to infinity on the right-hand side. Okay? And if you talk about end behavior, the right side of the graph and the left side of the graph, well, the right side is still going up forever, and the left side is still leveling out at 0. So essentially, all exponential growth curves, until you start with transformations, have the same information about them. Okay? Now, on number 3, on that third example, this graph is going to look different. I know it's going to look different. Why?
It's a fractional base.
Right, my base is a fraction that's smaller than 1. So that means this is going to be a graph representing exponential decay. So just like before, I need you to put that into y equals 1/2 to the x power. You can use 0.5 to the x. Okay. But if you're using a fraction, you need to make sure you put in parentheses. 1/2 to the x power. And then I need you to go to your table and I need you to give me a few points that I can plot on my coordinate plane. -3, 8, okay. -2, 4, 1, 2. Okay, and again, that same y-intercept, it didn't matter this is a fraction. Whatever number you got right there raised to the 0 power is 1. Alright, sorry, didn't interrupt. So we'll stop 1, 1/2. And then, they just keep getting, the decimals keep getting smaller and smaller and smaller. So, it's a little bit crooked, but it's the same shape, just reversed. And if you compare the order pairs of points on this graph to the first one graph where your base was 2, okay, the values are very, very similar. It's just the x's are negatives and positive. So domain. How far left, how far right does that graph go?
Negative infinity to infinity.
Yeah, still all real numbers. You can plug in whatever you want to for that exponent. You can plug in positives, you can plug in negatives, you can plug in zeros, you can plug in fractions, you can plug in whatever you want to. The range. Well, here's the thing about it. It's reversed. Okay, the position of the graph is reversed. This time the left-hand side is going up forever. Okay, and the right-hand side this time is leveling out. Okay, my horizontal asymptote is where that graph levels out, and it's still at 0. It's just the right-hand side is leveling out instead of the left-hand side.
Negative infinity to 0.
Okay, what's the lowest y value? Range is y's. Okay, what's the lowest y value? No matter which side of the graph it's on, what's the lowest y value that graph is trying to get to?
0.
It's still 0. And it's still going up forever. It's just, it's been reversed, or it's actually a y-axis reflection, okay? But it's still, 0 is the lowest y value the graph's trying to reach, and the other side is still trying to get to infinity, okay? Now, this is still the right side, this is still the left side, because x is going to the right forever, and then x is going to the left forever. But this is the one place where you do have a change. The right side of the graph, what is it doing? It's not going up forever now. What is it? Okay, it's leveling out at 0. Therefore, the left-hand side of the graph is doing what? Y-intercept is still that point, 0, 1. So essentially, all the information is the same. It's just the left-hand side goes up instead of the right-hand side going up. So, all right, so as we get started with the fourth example, as Dawson's trying to tell me, again, I know that graph is going to be exponential decay because my base is smaller than 1. And Dawson has told me already that the y-intercept is still 0, 1. Okay, and then, what other points did you tell me, Dawson? Okay, and there probably aren't as many nice points. Is there another one like on the side? Okay. And then maybe 1.6 repeating. Okay. So essentially the same shape, I'll miss a little bit. Essentially the same shape, but points are just a little bit different. Okay? Follows the same pattern as the previous graph, and all the information will be the same. The domain is the same. The range is the same. It still goes to 0 on the right, and it still goes up forever on the left. The y-intercept is the same, and the horizontal asymptote is also the same. Okay. Now, I'm pretty sure the video is going to cut me out for 15 minutes. So what I want you to do is to see if you can get everything filled in for number 5. I'll pause the video right now, and then I'll cut it right back on with all the information filled in. Alright, so for that last example, number 5, it is an exponential growth curve because my base here is bigger than 1, and all the information to the right is the exact same as any other exponential growth curve. But you need to let me know if you have any questions.